Integrity is ready for the event.
Good afternoon from the Space Coast of Florida, where 4 astronauts are about to suit up for NASA's boldest test flight in a generation. This crew could be the first humans to journey around the moon in more than half a century.
In just over 9 days, 4 astronauts traveled more than 700,000 miles through deep space, reached a distance of over 250,000 miles from Earth, passed within 4,000 miles of the moon, and became the first humans in over 50 years to make that journey. We're not talking about a symbolic lap around low Earth orbit. This was the full lunar circuit, the real thing, with 4 people strapped inside a capsule named Integrity, and every single system aboard it being stress tested against conditions no simulation can fully replicate. That data now sits inside NASA's mission record, and it just moved the agency's entire lunar timeline forward. Artemis 2 launched April 1st, 2026, and splashed down April 10th, a mission lasting 9 days, 1 hour, 32 minutes, and 15 seconds from liftoff to recovery. Let's walk through what that actually looked like on the ground. At 2:17 p.m. Eastern, SLS Block 1 ignites with 8.8 million pounds of thrust from 4 RS-25 engines and twin solid rocket boosters. Orion Integrity clears the tower carrying Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Cook, and Jeremy Hansen from the Canadian Space Agency. We watch the boosters separate cleanly at T+8 minutes. The core stage follows 90 seconds later. Then, 90 minutes after launch, the trans-lunar injection burn fires and pushes Orion toward the moon at 24,000 miles per hour. Earth shrinks to marble size in their window. Over the full mission, the crew travels approximately 695,330 statute miles, by some measures tipping past 700,000 when accounting for trajectory corrections. Their maximum distance from Earth reaches 252,756 miles, breaking the record set by Apollo 13 in 1970. That record stood because the moon happened to sit farther out in its elliptical orbit during that particular cycle. Same physics, different timing. At closest approach over the lunar far side, the crew holds at 4,067 miles above those pockmarked planes, close enough to fully exercise Orion's navigation stack, communication relay through the deep space network, and trajectory control under real gravitational conditions. Lunar gravity tugging at exactly the force the engineers modeled, locking in the free return arc without burning extra fuel. Re-entry comes in brutally, 24,527 miles per hour relative to Earth. The heat shield peaks at 5,000 degrees Fahrenheit, with orange plasma wrapping every camera angle. 2 drogue parachutes deploy at 26,000 feet, 3 mains at 8,000. Splashdown hits April 10th at 8:07 p.m. Pacific off the San Diego coast. Recovery teams from the USS George Washington have Orion aboard within 45 minutes. The crew steps out grinning, 9 days out there, and they look like they'd do it again tomorrow.
We actually get in the mock-up. In that enclosed physical space, we have to think through the hardware that they have, the cameras, the computers, their microphones to make these observations.
Now picture what those 9 days actually felt like from inside. 4 people, 316 cubic feet of pressurized space, no hatch to pop open, no fresh air, no reprieve from the hum of machinery running around the clock. Every detail was measured. The crew consumed over 118 pounds of food and supplies across the mission, averaging 2,400 calories per person per day, cycling through thermostabilized shrimp cocktail, rehydrated beef fajitas, flour tortillas with peanut butter, and even canned mackerel. No crumbs allowed to float free. Every meal is photographed for the record. Sleep averaged 6.3 hours nightly by actigraphy watch, dipping to 5.8 on lunar flyby night. Pure adrenaline pulling that number down, then recovering to 6.5 hours by the end of the outbound leg once blue light filtering glasses and white noise generators kicked in. The life support systems ran continuously, with electrolysis units recycling 92% of urine and humidity condensate back into drinking water through multifiltration beds. Output tested clean across the entire mission. The waste management system gets its first real deep space workout here, And on day 3, it gives the crew a problem. Undissolved fiber particles clog the macerator pump impeller. The system stalls. They switch to manual contingency bags for 14 hours, while Houston beams up an enzyme flush solution to clear the blockage. It works. Full function resumes by the end of day 4, and that in-flight fix alone is worth months of ground testing that no longer needs to happen before Artemis 3. In deep space, nothing is minor. A clogged pump 250,000 miles from home is a problem that needs solving with whatever you brought with you. This crew solved it, logged it, and handed the solution back to the engineers on the ground. Beyond the hardware, this crew carried something heavier.
My name is Christina Cook, and I'm a mission specialist for NASA's Artemis II mission around the moon.
Christina Cook flies as the first woman on a lunar mission. Her 328-day ISS command already built the physiological record for extreme duration, and the Artemis II radiation and cardiovascular data extend that record into deep space, heart strain matching male peers exactly. No unique vulnerabilities logged at any point across the 9 days.
My name is Victor Glover, and I'm the pilot for NASA's Artemis II mission around the moon.
Victor Glover pilots as the first black astronaut on a lunar trajectory. A Navy test pilot who logged 40-hour simulator marathons running engine out and abort scenarios. That precision shows up in the mission data when he manually pulses reaction control thrusters to nail the flyby altitude within 100 feet of the calculated mark.
My name is Colonel Jeremy Hansen. I'm an astronaut with the Canadian Space Agency, and I'm a mission specialist on NASA's Artemis II mission around the moon.
Jeremy Hansen represents the first non-US citizen on a lunar trajectory, Canada's deepest crewed mission ever flown. For the first time, a lunar crew reflects a broader picture of who is included in space exploration. But we should be clear about what the data actually says. All 4 crew members ace 150 cognitive battery tests across the mission, with spatial reasoning, reaction time, and memory recall hitting 98% accuracy even at apoapsis isolation. Bone density loss logs uniformly at 0.8% across the crew, consistent with ISS baselines and countermeasure protocols involving 2 miles of daily in-cabin cycling and treadmill sessions hold the numbers where engineers need them. The performance record is unambiguous. NASA's deep space certification now formally extends across gender, nationality, and background, and that extension is grounded in 9 days of hard physiological data, not projections. Here's what all of these numbers actually mean together. Artemis II didn't just test a spacecraft, it tested the timeline, because every system that held steady removes a delay from the schedule downstream, and every system that failed in flight and got patched remotely removes months of ground testing that would have been required otherwise. NASA scores Artemis II as de-risking roughly 80% of the crewed lunar stack. The waste system patch alone saves an estimated 6 months. The Star Tracker dropout and autonomous recovery certify the navigation protocol without a dedicated ground test campaign. 42 major subsystems delivered 99.9% uptime across the full mission profile. That translates directly. Artemis III automated docking tests move to Q2 2027.
What you're looking at now is the largest part of the Space Launch System, or SLS rocket, for Artemis III. It's called the core stage, and it's made up of 5 sections. Today, NASA rolled out 4/5 of it. The engine section was delivered last year. Crews spent about 3 years working on all of this in New Orleans.
Starship HLS orbital refueling demonstrations complete late 2027. The human lunar landing locks in for 2028. With hardware now certified against real conditions rather than modeled ones.
Now we're doing so because the Artemis astronauts are about to experience a solar eclipse from their capsule. And this is a solar eclipse that no one else on Earth will experience.
On April 6th, the crew swings past the far side of the moon, and for 57 minutes, a solar eclipse unfolds that nobody on Earth can see. The moon's silhouette completely swallows the sun's corona. Ruddy Mars burns 2 degrees off axis in the starfield. Christina Cook runs GoPro, capturing 4K 360-degree panoramas, with real-time downlink feeding that footage to 5,000 schools worldwide. Handheld cameras map fresh science simultaneously. Boulder tracks scarring fresh impact ejecta. pyroclastic vents showing glassy flows never imaged from prior orbiters. Jeremy Hansen sketches geologic timelines mid-pass, carbon pencil on mylar, feeding observations directly into lunar surface models back on Earth. The crew names craters live over S-band. Integrity Basin honors the capsule, a 12-kilometer walled plain at 15 degrees south, 160 degrees west. Carroll Crater pays tribute to Reed Wiseman's late wife, a 7-kilometer pit now provisionally charted at 22 degrees north, 145 degrees east. From the far side shadow, Wiseman reads poetry. His voice carries calm across that 1.3-second light delay. Global viewership peaks at 80 million. Within hours of splashdown, the 45-day rehabilitation and evaluation program begins at Johnson Space Center's Neuroscience Lab. Tilt table testing in hour 1 recalibrates the autonomic nervous system. Orthostatic hypotension drops hold under 20 millimeters of mercury systolic. Everything looks nominal from the first assessments. Cardiovascular conditioning ramps through weeks 1 and 2. VO2 maximum climbs back to 85% pre-flight capacity through pneumatic anti-gravity compression protocols. DEXA whole-body scans quantify 1.2% bone mineral density loss, concentrated 70% at the hips and spine, consistent with the in-mission actigraphy data. Balance platform assessments show that vestibular recovery is improving by 25% week over week. Full-body MR is confirmed 0 microclots, lesions, or white matter abnormalities across all 4 crew members. Engineers run parallel analysis on every system Orion carries. Heat shield AVCoat blocks are X-rayed layer by layer, with ablation tracking exactly as modeled. Lithium-ion batteries tested at 98.7% full-cycle efficiency. Service module reaction control thrusters log 0.4% total wear across 1,200 pulses, well within margins. 30 terabytes of raw data across life support, radiation, sleep cycles, crew psychology, propulsion performance, and trajectory mechanics now feed directly into Artemis 3 preparation. The crew requalifies for Artemis 3 backup roles by the May 31st deadline. 9 days in deep space, and they're cleared to go again within 2 months. Artemis 2 proved NASA can send humans on the full lunar circuit and bring them back intact. That part of the architecture now carries a certification stamp from real conditions. The pressure shifts accordingly, away from proving the concept works, toward building the operational cadence that makes it routine. The international architecture moves with it. ESA commits Ariane 6 to lunar logistics. CSA eyes Gateway Station crew handoffs with 2 confirmed seats in the 2029 rotation. JAXA incorporates the Orion Waste System fix into planning for the H3 lunar cargo mission. Commercial players accelerate. Intuitive Machines bids $100 million for regolith ISRU contracts. Blue Origin targets 2028 water ice mining proofs at the South Pole. The Mars 2039 transit architecture now validates against Orion's 14 millisievert deep space radiation benchmark, and 1,000-day habitat simulations begin incorporating the validated waste, radiation, and sleep datasets that simply didn't exist before April 1st. We've moved from demonstration to operational planning, and the programs downstream from this mission are treating it accordingly. Nearly 700,000 miles. 9 days in deep space, the first human returned to lunar distance in over 50 years. Artemis 2 confirms the architecture holds under real conditions, and the programs building on that confirmation are already in motion. The moon is no longer a destination we're working toward proving we can reach. Artemis 3 is in final preparation. The hardware is certified. The crew data is in the record. What happens on the surface when we get there? That's the question this decade closes with.